Hi, everyone. My name is Khadija, and today I will present the paper titled Health is Wealth, Evaluating the Health of the Bitcoin Ecosystem in GitHub. So cryptocurrency is a virtual or digital currency which is used as a medium of exchange in online transactions. And it is based on cryptography and blockchain technologies. Bitcoin is one of the first cryptocurrency which was created in year 2008. And according to the coin market cap, it is one of the leading cryptocurrencies in the market right now. Software ecosystems, they are defined and typified around actors, incentives, common technology, and environment. And there are many definitions given to the Bitcoin ecosystem by the researchers in this field. For example, Olga et al. Consider software ecosystem in his study as a collection of software projects which are developed and evolve together in the same environment. The motivation behind studying Bitcoin is that it is one of the leading cryptocurrencies, so it is important to explore its health, the health of the ecosystem, and investigate whether it has formed a healthy software ecosystem or not. And furthermore, the total supply of Bitcoin is $21 million, and the worth for Bitcoin mining is 6.25 Bitcoins. And moreover, the estimated number of coins mined per month is 108,000 with an operational cost of 18 million US dollars. And studying Bitcoin in GitHub, GitHub is one of the most favored and mostly used open source development platform by the developers. And moreover, it hosts 100 million software repositories, and over 40 million developers are contributing and sharing repositories in GitHub. And also Bitcoin's main repository is hosted by the GitHub. The objective of this work is to explore Bitcoin ecosystem in GitHub by categorizing its projects and evaluate the health of the Bitcoin ecosystem in GitHub. And we aim to answer the following three questions. Question number one is that how the Bitcoin ecosystem is represented in GitHub, how healthy is the Bitcoin ecosystem in the GitHub, and what are the trends in the health of the Bitcoin ecosystem. The related work around software ecosystems is organized around three main concepts: architecture of ECs, identification and evolution, and health of ECs. In architecture of ECs, some researchers think that software ecosystem should be around project relevance. Some think that it should be business oriented, while other thinks it should be around developers or organizations. In identification and evolution, mostly researchers studied programming languages, for example, Python and R. They are extensively studied by the researchers in this field, but also mobile ecosystems and development platforms. They are studied. And in health of ECs, researchers try to define metrics based on socio-technical perspective to determine the health of an open source software ecosystem. Our research is focused around the well-known Bitcoin ecosystem, which is, and we follow the definition given by Johnson et al. In his study. And he considers a software ecosystem as a software collection. Software ecosystem is a set of projects and actors functions around a common technological platform or a market, and they exchange knowledge and resources. For the data set, we use GStoring database, and we identified Bitcoin repositories by searching the keyword Bitcoin in the name, description, and README file of repositories. And we also apply some certain filters. For example, we removed all the deleted repositories from the data set. Furthermore, we removed all the forks. We consider all the master repositories, and moreover, we are considering just active repositories in terms of that its last commit should be within the last 6 months. And moreover, we consider only the repositories with at least 2 contributors. And so we ended up with 581 repositories. After manual categorization, we found that 50 of these repositories are completely irrelevant. Even they have the Bitcoin keyword in its name or description README file, but still they are about something else. And 50 of them are no more available. When we were trying to clone each repository to collect the source code metrics, we were not able to find the 50 more of these repositories. So we ended up with 581 repositories from GitHub in our data set. So this table shows the features in our data set, and it includes both social and source code features. For the categorization of the projects, we followed a semi-manual process, and we analyzed the selected GitHub projects based on their name, description, and README files. For example, for the development, if we came up with any developed implementation, IDE, protocol, or library, any kind of tool, that is categorized as development. For example, for documentation, if a repository is having any documentation about Bitcoin, that is categorized as documentation. For the health analysis, we classify the projects in 3 classes of health, and and for that purpose, we introduce 4 categorical features in our data set, which is popularity, complexity, activity, and age. And we use quartiles as thresholds to classify these repositories based on these 4 categorical variables, which is based on the features in our data set, into different classes of health. Furthermore, for the trends, we did a quantitative analysis of the trends considering all the defined health metrics for the ecosystem as a whole. Coming to the results, we will look into the results for each of the research questions. So our first research question is that what categories are representing the Bitcoin ecosystem in GitHub? So after manual categorization, we ended up with the 9 categories, which is data analysis, development, documentation, mining, node, payment, services, trade, and wallet. Where development is the leading category among these ones, with the highest number of repositories with 223, and also other features such as issues, watchers, developers, and commits. How healthy is the Bitcoin ecosystem in GitHub? So overall, because majority of the projects in the Bitcoin ecosystem, they demonstrate low risk. So it is a good sign for the health of the ecosystem as a whole. And moreover, because 17% of the projects appear to be healthy, and only 15% of the projects are deemed to be at risk. Question number 3 says, what are the trends in the health of the ecosystem? So in terms of commits, figure 7 shows the average number of commits per year per repo. And we can see from this figure that the number of commits is increasing in the first few years, except 2013, but after 2014, there is a decrease in the number of commits. Figure 8 shows the average number of commits per category and per year. From this figure, we can say that mining, development, wallet, and node is the persistent categories throughout the years, while other categories emerge in the later years, one by one. And in terms of contributors, we look into the loss of contributors, collaboration of the contributors, and top collaborating categories and categories which lack any collaboration of the developers. So figure 11 shows the loss of contributors, and we can see that we are losing more contributors throughout the years. And for example, in 2015, there is 89 developers who contributed or committed to the ecosystem who didn't do any commits in the later years. And figure 13 shows the developer collaboration, and we can see that 88% of the developers are contributing to only one project, while 12% of the developers are contributing to more than 2 projects. And for the top collaborating categories, we can see development, services, and node. They have some developers who are contributing to these three categories at the same time, while wallet, trade, and mining, they lack collaboration of developers. In the term of vouchers, in figure 17 shows average number of vouchers per year per project, and we can see that number of vouchers is decreasing from year 2010 till year 2013, but after 2014 there is a slight increase in the number of vouchers in this ecosystem. Okay, and I will conclude the presentation with some of the main findings from the study. The first is that Bitcoin software ecosystem in GitHub is limited compared to the big picture of Bitcoin ecosystem. And development, node, and services are the leading categories in the ecosystem, while documentation and data analysis have emerged in 2014 and 2016 respectively. And about the health, we can say overall the health of the ecosystem seems very well, because 70 of the projects fall into the low risk, and while only 15% of are classified at risk. And there are some implications for the different researchers in different communities. For example, for the researchers in Bitcoin community in GitHub, they can, to increase the sustainability of the ecosystem, the community should apply a number of actions to increase the retention rate of the developers in the ecosystem. And similarly, to improve the code quality and better understanding of the community's goal, and they should put more effort into various kind of documentations. And the Bitcoin ecosystem should facilitate better knowledge transfer between different categories to be able to maintain a sustainable software ecosystem. And for the researchers in Bitcoin community, we can say that there is a lack of collaboration between developers within the GitHub and, and across different categories. And we suggest that the Bitcoin community should focus on knowledge transfer and expertise development across different categories in the ecosystem. For the researchers in the software ecosystem research community, we suggest that they should enrich these health metrics by considering source code quality and metrics. And another is a question to this community, that how one can define an open source software ecosystem around a potential community which lacks any documentation, code, or any code dependency. There are some threats to the validity of the study. The first is the quality of the GH storing dataset. The second is the heuristic-based approach that we adopted to classify the GitHub projects into different classes of health. The third is that in trends analysis, the data for 4 months of year 2018 is projected for 12 months. And human bias and error during manual categorization is also a threat to the validity of this study. And furthermore, categorization of the Bitcoin project is dated April 2018. There could be, and there is more projects in this ecosystem after that, which we don't have it in our study, and which is not part of our study. I will end the presentation with the takeaway message. So while the Bitcoin ecosystem has a limited presence in GitHub, our research shows that the software ecosystem is in good health overall, based on the health metrics used in this study. These are some references used in this presentation, and that's all. Thank you.